Hey, welcome back. And now we get to deal with higher order derivatives as they apply to trigonometric functions. So how do we deal with that? Well, we're going to see what we find. So they want us to find the first four derivatives of sine x. Okay? So in this case, y prime equals what? Derivative of sine is cosine. So now we're going to take the second derivative. So that means we're going to take the derivative of cosine. Well, what's the derivative of cosine? Negative sine. Now, we can look at this as like negative 1 times sine and treat it like a constant multiple rule, right? So now if I take the third derivative, well, it's going to be just a constant multiple rule, which means the negative 1 is going to be just kind of factored out, and I'm going to take the derivative of sine. Well, what's the derivative of sine? Cosine. So the third derivative is going to be negative cosine x. And now we're going to do the same thing. And in this case, remember, the derivative, this is given like negative 1 times cosine. So cosine, the derivative of cosine is negative sine, but we have negative 1, so negative times a negative positive. And look at that, we end up right back where we started. And so now we see that we have a pattern here. It seems like every fourth derivative, right? 1, 2, oops. So every fourth derivative winds you up back at sine. So if you start with sine, every fourth derivative brings you back. If you start with cosine, every fourth derivative will bring you back to cosine. If you start with negative cosine, every fourth derivative will bring you back to negative cosine. So that's the pattern. So now we can use this pattern to simplify higher powers of sine, or higher derivatives of sine that are much higher. Okay? For example, here we want to find the 74th derivative, right? Well, how would we do that? Well, I don't want to take 74 derivatives of this thing, so let's use the fact that it repeats itself every 4 derivatives. So what I'm going to do is I'm going to write this as this exponent as a multiple of 4 plus a number, right? So what's the largest multiple of 4 that goes into 74? Well, let's see here. So that's going to be 72. Right? So 72 is the largest multiple, and then I have 2 left over. So I'm going to write this exponent as 72 plus 2. And I'm going to write this one as 72 plus 2 of sine x. Well, I can ignore the 72 then, because I know that if I take 72 derivatives, I'm going to go right back to sine. So this would be the same as if I just took the second derivative with respect to x of sine x. And of course, we know the second derivative is negative sine x. And we're done. Have a great day.